Hey there, take 1 second to hit and smash that like button and let's get started.
All right, so different forms of machine learning. Don't get stuck on one type of model, and that's why I tried to loop initially. Try to use the best one that fits the scenario you're working on for a more broad case of AI. So support vector machines, random forest, logistic regression, k-means clustering, k-nearest neighbors, Bayesian models, and neural networks. And I kind of put it in order of what I feel is most used down to at the bottom. So all the hype now, of course, is in neural networks. And then Bayesian models is something I personally like using because they have a very accurate statistical approach like neural networks. All right, so support vector machine. It's pretty much a high-dimensional system of vectors. Shown over here where you can kind of break or classify 2, 3, or more systems apart from each other using a hyperplane in the middle. I'm not going to go into detail about this because I just don't have the time for each one. But you can see here, there's a classification system that separates 2, 3, 4, 1,000 classes from each other. And you're able to predict, based on the next value put into the system, if it fits in this region, you can identically, classify it as class 2 or as class 1. And I only show you 2 classes here, but like imagine there's many more. This hyperplane here separates the differences between the two, and it allows you to kind of separate the different classes. Moving on.
Is class just like a generic classification?
Classification.
Okay.
Yes. Oh, did I go backwards? Okay. All right, so random forest is focused mainly on going through or traversing through a system and trying to figure out what the best solution is. Also another statistical process as well to figure out that everything we talk about today is based on classes. Most of the time it's class-based, classification-based. There's other levels, but this is classification-based we'll talk about. And when I mean classification, what I mean by that is recognizing what something is. So I can recognize a person like Marina, I recognize her, or I recognize a chair. I can recognize the differences between the two. So if I look at an image, for example, I can recognize the different parts in the image, and that's classification. I can classify it through this network. So random forest, for example, I can recognize different items from that. And this, again, is numerical. Now, logistic regression could be used both in a binary system or it could be multinomial, which is not linear regression, which you probably learned in school. Linear regression is typically just a slope, and you separate the two apart. Logistic regression it can be multiple variables put into this, and it's separated through some line, as shown here, of what is true or false. And that, again, once you build that model and you add or introduce a new value to it, and it kind of helps you determine which side it's on and classify it again. All right, so same thing I mentioned before, logistic regression. Now this is the multinomial version of regression. This is now, again, classification, but at a high dimensional vector space. So more than 5, 10, 100,000, depending on your compute speed.